You're talking about this problem where there's like an ice lake, a stake in the ice, there's a rope, and there's this thing going around in a circle. This is something we see every day, right? No, I'm just kidding. Anyway, so I drew it from the side. So I got weight, normal, and then tensions this way. Looks like what you have. So this is all looking good. And then you got normal, tension, mg. So this one's mg, this one's normal, this one's tension, and this vector here will be our net force, which is in the same direction as our acceleration towards the center. So that's mv squared over r, and we're assuming uniform circular motion, which means the idea of uniform means you're going with a steady speed, and circular refers to a circular path. So when that happens, when we have uniform circular motion, we can assume that centripetal acceleration is v squared over r. That's why our ma is mv squared over r. So you've got it. You've got tension equals mv squared over r, and you've got normal equals mg. That's all we can say from that. But I do love for you to work on like proportional reasoning. So what's the relationship between tension and radius? Tension is proportional to
1 over r.
good. And what about mass?
Directly proportional.
Yep. And what about speed?
Speed squared.
Okay. So the kinds of questions I really like are like, okay, if you change this apparatus and doubled the radius, right? You made the string twice as long, so instead of r it was 2r. What would happen to the tension in the rope then?
It would.
Yeah? You sound really unsure.
Okay.
So, yeah, you can just imagine putting you're making r bigger, so t has to go down by 1/2. It's an inverse, that's called an inverse relationship. Now, what if you took the same apparatus and you made this thing go 4 times faster? How much more tension would you get?
6.
Yeah, isn't that incredible?
Yeah.
I mean, that's where this proportional reasoning is really useful. Once you have an equation like that, you can answer all sorts of questions. And sometimes you don't even know what the equation means, but you can actually get a sense for the equation and the relationships just from the mathematical reasoning. Did that answer the question?
Yeah, that's good. I got it. Thank you.
You're awesome.